Hello everybody, and welcome to another session of me programming daily. Today, drakon renderer again, and I'll be working on this issue. This function DC paths with valent points. I really only need it for the purposes of troubleshooting the algorithm, but really what I will need from it is just the valent points to be injected back into the collection of icons. So let's get started. I've already checked out the branch locally and prepared a function signature for it. Let me just check if everything's okay with OBS, which likes to play a trick on me. All right, so I hope you have your drink of choice. Let's work on it. So I'm thinking this function is performing well, and I can still use it for troubleshooting. So I'm not going to delete it. I'll just put its result through this function, only valent points. So only valent points will accept this type as an input, and it will return just a list of icons identified as valent points. What I would like to use is a map for this, so that as I iterate through the list of lists, I can fish out the valent points and put them in a... Do I even need a map? I don't need a map. I can just use a regular list, because valent points will never be duplicated. So forget my comment about the map. This is not correct. I just want to build it and format it, because there will be two folds. One that iterates through paths, and the other one inside here that iterates through all elements in a path. We will deal with all these suggestions later. For now, let's just resolve the issue at hand and ultimately close this chapter of injecting valent points. By the way, if time allows and if I have the energy, I'll try to explain these, which is a collection of paths generated for the entire graph, where we treat the title icon, which can only be, there can only be one title icon, as the only divergence point, and the end icon, and again there can only be one end icon, where that end icon is treated as the only one convergence points. I get correct paths, and it is very tempting to just balance these paths, but there are some catches that are not really all that obvious. If time allows, I'll left a quick comment here. If time allows and if I have the energy, I'll try to explain it. But I don't think rebalancing the whole graph without finding all convergence points, all divergence points, is going to work. At least that's what I'm convinced about now. Anyway, let's get back to our algorithm at hand. Let's format. Sadly, nothing formatted here. So let's remove this for a second. So this is our second fold. Oh, we can always do this. And now let's display all this. So here we're expecting to see 2. Perfect. So that's a lot of troubleshooting. And now, since we can only we can already isolate valent points, let's add them to this collection. So from this moment on, we do not need icons, and we shouldn't use icons. We should use icons with valent points. So here. All right, I'm curious how it actually looks. And now this works, but I have a feeling I've checked in, or I've committed, these valent points. They have injected manually. So let me remove them. And here, we're going to restore the previous state. And that doesn't work. Why is that? We don't need this one anymore. Let's see the layout. Okay, so this is incorrect. Okay, so I think the issue is resolved, but we've introduced unwillingly, well, not knowingly, another issue. We do have these valent points provided, but nothing is pointing at them yet. Let's see what the issue says. Yeah, we're returning valent points, correct. But this function also modifies dependence or updates dependence. Let's commit this for now. Now we need another issue. So now, after a short break, I'll try to start figuring out how we could resolve that issue as well. All right, it looks like we're back after a break. Let's not forget to switch to the code view, and yeah, let's get back to the issue. I think what we can do is, and the only valent points, actually make a change and implement a new function called updated icons, which takes all the paths produced by this function, DCE paths with valent points, and it will interestingly have the same signature, but you know what, for now, let's just return the map, and that map will have all valent points and all the icons. So string is still going to be the key, but the value is going to be just one icon, if I'm not mistaken. Here I'm planning to use a fold, so we can reduce it straight away. Will this work? I still have a little bit of time today. This works. Perfect. Let's just check. How to skip duplicated inserts. Oh, maybe let's also use insert with. we're not going to be combining the values. We'll be simply taking the first one that is found. So most of it will probably be just the same thing. Two folds. This function is going to replace only valent points. And here, simply, we're not even going to check what kind of icon we're dealing with. We're just going to do I1, I2. We're going to return I1 because they will be the same. Or maybe insert. So we have key, value, map. Maybe insert would be easier. So here, this we don't need. Map is going to be our ACC2, which starts as empty. Oh, this is interesting. We start with an empty accumulator. And here, we don't start with an empty, we start with an ACC1. And the result of the second fold is going to become what? ACC1, I think. So we don't need this. Key is going to be single icon, and value is going to be single icon. Is it that simple? I'm sorry, this is not called yet. Updated icons. So now there's a distinction here. Prime is the new version, the old version is here. Oh, that only returns the paths. Goodness. Okay, I think I'm going to start wrapping it up for today. But in preparation for tomorrow, let's return something like this from the updated icons. Or maybe updated icons really should be of type like this. Obviously, this is going to be commented out for now. So here we have the paths. What I did forget about is that paths that will be supplied here will possibly not have all the icons. So we need to provide them. And as a result, we return not a map this time, but a collection like this. So we read it as paths, all icons with valent points. But this I think we can tackle during the next session. Having said that, I think pretty good progress today. Thanks very much for sticking with me. And yeah, we're, I think, getting a little bit closer to applying this function DC paths to all types of DC paths we have found. Just a refresher, we've only polished it up or polished the program up for DC paths starting at icon 3 and ending at icon 6. So we still have a lot of paths to go through. But I think the progress so far is promising. And if we do that, we should be in the position where valent points get injected automatically in the entire graph. And that should simplify the layout of the diagram, or the layout engine, and also the piece of the program that renders connections. Because you remember that initial connection that we saw during the last session was very incorrect. Anyway, good progress. Thanks very much, everybody, and I'll see you next time.